So today I want to start talking about graphs. Now, the word graph, unfortunately, is used to mean two completely different things in math. And so the one that many of you are probably familiar with is this kind of thing. Right? I have like a graph of a function. And this is not the kind of thing that we're going to be talking about. So the thing we're going to be talking about is related to the idea that we very often want to model a collection of things that are connected in some ways. So there's some set of things and there's some connections between them. Right? So your book gives this kind of example. Maybe this is like some kind of company that's got different computers, or maybe even like giant buildings full of computers in different cities, and they're connected by special network connections. Okay, so each dot here represents a city, and then each line connecting these dots represents some kind of network connection, perhaps. Okay, and we'll talk more about this example in a minute, but this is the kind of thing that we're talking about, some things connected. So what's the definition of a graph? So a graph, G, sometimes we'll write a pair of V comma E. So it's a set of vertices V. They're also called nodes sometimes. So you'll hear people use those terms, vertices and nodes, interchangeably, pretty much. Together with a set of edges E. Okay, and each edge we say connects two vertices, and those vertices are called its endpoints. Okay, so we can see some of that going on here. So these dots here, the cities, represent our set of vertices for this graph, and these lines that are drawn represent the edges. Notice that, for example, this is a vertex here, so there's nothing in the definition that says that every vertex has to have some edges connected to it. Okay, so this vertex happens to just have no edges connected to it. Notice here these edges like cross in the middle, but we don't care about that. There's not a vertex there. And in general, right, when we talk about graphs, we often draw pictures because it's a very helpful way to think. But we don't actually care about the way it's drawn. We only care about how things are connected. And so I could move these around, I could draw the edges all wiggly, I could make the edges cross each other in funny ways, and it wouldn't change what graph this is, right? All I care about is which cities I have and the different ways that they're connected to each other. Okay? So there's a few variations that we can have here. So for example, sometimes we could allow multiple edges between the same two vertices. Multiple edges between two vertices. Okay, so for example, in this picture here, maybe the connection between LA and Denver is really super important, and so there's actually two network connections between them. And if we wanted to model that kind of situation where we could have multiple distinct connections between the same 2 points, then we could allow having multiple edges. So I don't know, maybe there's even like 3 between Denver and Chicago. Okay, so we could allow this or not, depending on what we want to model. Okay, the other thing that sometimes we allow, an edge can connect a vertex to itself. A vertex to itself. Again, sometimes we want to allow this, sometimes we don't. In this scenario, maybe maybe in San Francisco there's some, that they like to test things, and so they have a network connection set up that actually connects it to itself so that they can test things going over the network but coming back to the same place. I don't know, right? But we could draw those as little loops, like that. And we call these kinds of edges, we call them loops. Okay, so these are called loops. And the last thing for now, sometimes edges have a direction. Okay, so in the definition here, I just said that an edge is associated to two vertices, but we could say that it's associated to a particular ordered pair of vertices, like there's a vertex that's first and a vertex that's second, and the edge goes from one vertex to the other vertex. And usually when we do that, we draw it with little arrows, so maybe we would have a little arrow here, and an arrow here, right? That would be modeling in this situation if these network connections are one way, perhaps, right? So you can send data from San Francisco to LA, but not vice versa. And so that would be a scenario where we would want these edges to have a direction.